Hello, welcome back. In one of my previous videos, I explained how this worked, which is a calculator in Minecraft, and it can calculate any number, adding or subtracting up to from the largest number being 255 all the way down to what would it be, negative 128. So that's pretty cool, but it's not really a computer necessarily. I mean, it computes things, but you can't program it. So I've been working on something just a little bit more complicated. So this is my first true computer in Minecraft, or it will be when it's done. So this right here, you notice, looks very similar to what is in the previous computer, or the calculator. And that's because it is. This is the addition part of the computer. I have extended it to be twice as large so it can handle numbers up to 2 bytes or 8 bits, which would be uh, numbers bigger than I can do in my head. And here you can see it says add. I've tried to label things to keep things straight. So this entire thing is known as what's called the ALU, or Arithmetic Logic Unit. So most computers have more than just addition and subtraction. You also have what I've added here, which is we've got bitwise AND, which basically means, like in another video, I explained how logic circuits or how logic gates work. Basically, if you have, like in this case, this is AND, so it only sends out an output if this and this are on. It basically does that for each individual bit in your 8-bit number. And then we have an OR, same thing, but with OR gates, and NOT, which is the same thing, just with NOT gates. And here we have shift left and shift right, which just moves the entire number one digit farther to the right or to the left. If you think about in base 10 or normal numbers, if you have, let's say you have the number 12. If you multiply by 10, which is the base in base 10, normal numbers, then you get 120. You basically just move it over to the left and add a 0. If you divide by 10, you get 1.2. Or if we round it, you just get 1. And basically, you shifted everything over to the right, or divided by 10. That's basically what this does, but because binary is base 2, it's the equivalent of multiplying or dividing by 2, which either shifts everything left and adds zeros, or it shifts everything right and rounds any numbers that are being removed. So all of this will work together to form the ALU, which will do basically all of the processing of information. Now you might be wondering why this doesn't have like multiplication, for instance. Multiplication can actually be handled using software. So this is all what we would call hardware because it's all physically there. It's physically made up of components in the computer. However, software is basically programs that we write to use the hardware. And as it turns out, there are actually multiple ways to do multiplication using these that basically you don't need a separate thing for multiplication. You can handle that using software. So you can do addition. You think multiplication is just addition repeated a bunch of times. Well, you can do that. Or there's actually a faster way to do it by shifting or by looking at it basically a digit at a time, kind of like you would do it by hand. Maybe I'll make some video about that sometime once it's working or something. I don't know. We'll see. So basically, the ALU is the only part that is completely done. Actually, that and probably the control unit. I think the control unit's done. I kind of forget. I also didn't really clearly label these as well as they should be. this is what I'm going to call the control unit, um, which basically controls stuff as it might sound apparent. Okay, let me back up. So there is a lot that has to work together in this. So it's difficult to explain one thing without like explaining everything else. So the way a computer works, you have memory, and then the memory connects to you have memory, you have the ALU or like the processor, and then you have control of the processor based off of like instructions that is given. So in this case, I'm just going to have one set of memory that holds both instructions and uh, information. Well, instructions are information, but instructions and not instructions. And so it will pull from the memory, which will be over here. And if it's an instruction, well, it should only be pulling instructions. Then the instructions, which will be binary numbers, will come over here. The instructions will have 4 bits or 4 digits that specifically, that 4-digit code will tell it what operation is being done. And basically, all of these circuits send out a signal to each of these, and through some fancy redstone workings, it chooses which one of these to get a signal from, which is called, I believe it's called a multiplexer. I kind of forget. But you can do this in Minecraft using something called a comparator. So if you send a signal to a comparator, if this signal is coming in, so this is the output from our operation, and this is the control signal. If the control signal is on, this does not send out a signal. So the idea with this is every signal is on except the one that you want. I'll probably make a video that talks more in depth about that once it's actually working and it's like I can give examples. This is more of a summary. Yay, it doesn't work. So this is where the memory will be eventually. This is more control stuff that is going to be an absolute pain to do. But all of that will basically decide which memory slot to pull from. This is me playing around with trying to figure out how to store memory and set memory. And over here is where the signals will come in, because you'll have two numbers that can come in, like for addition and subtraction or multiplication or whatever. And yeah, so that is pretty much how it works, kind of, sort of. I will update this channel with another video once I've like finished something else with this, but progress is very slow on this because I've got other stuff to do, so I really have no idea when that's going to be. But stay tuned in the future for this working, or at least the next stage of it working.